Hi guys, my name is Emmanuel Joseph, and this is express.js the OOP way. I'm sure a lot of you are familiar with OOP already, and most times I've noticed like when people write express.js these days, they tend to use like a much more functional approach to express.js, but I've been working with like express.js more lately, and I wrote an architecture that is much more like using the OOP approach, and I noticed that like there are a lot of advantages using OOP generally over the regular functional approach in express.js. So I want to share some of those tips. But you might be asking, why OOP? Well, OOP in express.js can make your code more testable. It's easier to like unit test it makes your code easier to unit test, and we know that unit testable code is maintainable code, and that brings us to the next point: maintainability. OOP makes your code the OOP approach or OOP based architecture makes your code easier to maintain, because programmers can implement new functionalities like on their independently, because you have an interface that they can then develop like an implementation independently, and you can plug it into your code and everything works fine. It makes it easier to introduce new features. Also, it makes your code comprehensible. If you write your code well, it's easier for anybody to like look into your code and like trace it line by line and understand what's going on. So how do we do this? So you can look at this is a simple application I built for a client, and here you can see this is the entry point into my application, and all you can see in the entry point is basically app.startExpress server, which is like pretty much straightforward. And by the way, I'm using TypeScript. I believe TypeScript makes like it's easier to write object-oriented programming in JavaScript, and it makes code completion also better in most IDEs. So I always recommend TypeScript, especially in like large scale project that you're trying to work on. So if you look at my app class, the app class is what ties my application together. It's where I instantiate most of my controllers and connect them to Express, where I start connect to my database also. So basically this is like my God class, is what ties the entire system together. And if you look at the class, I have like I'm instantiating express.js here as a property. So it's not accessible in the entire application, it's just like here. There's the event emitter that I wrote. This is to pass events generally within the application. Then here, if you look at this interesting method here, is the private method register controller. Here, basically what we're doing is we're registering all the controllers we've created, and I'm sure you're familiar with like the concept of controllers. A controller is basically how you accept requests from the client and respond and send response to the client. So you can see that I have like my controller. I'm making the controller and I'm registering the routes of that controller. You can see here this is actually where I'm instantiating those controllers. When you see make lender, it's like basically instantiating those controllers. Then when all is said and done, I'm starting. So this is the start express server method that you saw earlier, and what it does is just register some plugins for Express, and also I'm starting my MongoDB, so because I want to be able to connect to the database. Lastly, I'm registering the controllers here, and I'm listening to on a particular port that was provided. So when we look at register controller itself, you can see that let me use a simple controller. Let's use the authentication controller for an example. You can see we are doing this express.use. Usually you just have like express.use, but because we are using the OOP approach, because so we are like calling it as, so basically Express introduced major changes and all of those things. It's easier to maintain our code to like adjust to those changes, because we have one single point where we are actually referencing Express and not across the entire application. So we have make authentication controller. So this this method here basically is a private method, and that's what I was referring to about encapsulation earlier. Like it's hidden from external factors, so you cannot basically you cannot call make authentication controller except you extend app.ts. So anyways, new authentication controller. So our authentication controller, for us to have an authentication is basically the login in the app, the login endpoint in my app. And by in our authentication controller, for us to authenticate the user, we need to have access to the authentication database. We need to have like an encryptor, something that like hashes the password that the user provides and compares it to the hashed password on the database. And we need a JWT authenticator, basically that helps us like tie the user we fetch from database and say this person hash their user ID and says this is the current authenticated user. Anyways, you can see I'm passing that into the constructor. I'm creating those things as like instances or properties. Now this is the next interesting thing. So we have like register. You can see I'm passing the router from Express into like a private property called router. And the router now is what we then try to we return this router that we are getting. We are basically setting the login. So we have a login method, which is also private. Then we register it at the handler as the login property. So if you look at the login method here, login method returns a callback function, right? Which in express.js we understand as function handlers. So this handler is what we then like interact with. Then you can see I'm calling, like, if you read this code line by line, you'll be able to understand to some extent what's going on here. So we're saying the DB from the DB find user by email or phone number. Basically we are providing but then we are just providing email here, and once we fetch the user, we want to be able to use the encryptor to compare the password that we have, like the password the user provided, that's request.body.password, that's the password from the client side, to the password we actually have that is hashed. So we are using the encryptor to compare both to see if it's actually true. So if it's true, if it's not true, we are returning with an error like you're unauthorized, you don't have access to the platform. But then if it's true, we are now using our authenticator, the JWT authenticator, to log in using ID. So basically we are logging in the user using the user ID, and we are then saying, okay, take the status code, okay, and we are responding with that user, passing the token that we got from that user. So because it's the token that they use to the bearer token that they use to actually access other endpoints that is using the middleware. And we are responding with errors in case there are errors. So that's basically the register router. So you can see that we return this router. So this is what makes like our application modular. We are using the modularity routes for express.js to handle the route. So when we return this router, we register it in our app.ts as in the register controller. You can see when we instantiate the authentication route, we then called the register route, which is the only public method on our controllers. Then after that is done, you can essentially see that. So now imagine in an instance where, for example, we want to change from MySQL to MongoDB. Because of our approach of using dependency injection, we'll be able to like first of all, another person can basically go and just write, taking this our interface here, our AltDB interface, which just says find user email. Anybody can go and implement this because they know what they are expected to return. This is the power of TypeScript and what we are trying to achieve. They know what we are expected to return, which is like authentication user, which is a promise, and they know what to expect, which is email and phone number, either of them. So they should be able to like implement independently another implementation of this interface and come and just easily plug that back in here they can easily plug that back in here and it will just work out of the box. We don't have to like start looking for everywhere in this code and all of those things. In the functional way, you have to start tracing and all of that. But yeah, you just have an interface, you know what to expect, and you can like return what you need, and everything just works right out of the box. So those are like the advantages of like OOP approach. If you look at the implementation of the ODB itself, so Mongo ODB, so this currently uses MongoDB actually, not MySQL, sorry. But you say so you can see that the all the information regarding MySQL is actually done here. You can refer to this like as a repository, but I prefer to call them adapters basically. So it's because a repository is also an adapter pattern. So this adapter basically has like find user by email that is being implemented, and you can see I'm just writing like a simple query that checks whether the email or the phone number matches. Or so for example, if the user provides us with an email, I don't want to bore you with the implementation. What is important is the architecture. So we then have like our adapter for the Mongo DB. So that's essentially like a very simple approach. But I hope this session actually helps you understand the advantages of this OOP approach and how to implement your own. If you have any questions, you can drop comments, and if you have any contribution to what I was talking about, please share. Thank you very much for your time. Bye.